We're embarking on major applications of annuities. In chapter 13, we're going to be dealing, in chapter 12, we're actually going to be dealing with leases, chapter 14, mortgages, and chapter 15, bonds and sinking funds. So what I would like to do right now, just to summarize and supplement some of the main ideas that we cover and might cover in class from chapter 10, 11, and 12, and that would give us pretty good start with major applications for the remaining of the course. So I'd like to start first with main definitions and classification of annuities. So again, an annuity is a series of equal payments at regular intervals. An interval could be a year. That's traditionally was annual payments, but now we can use we're using actually loosely. So it could be every month, every 6 months, every quarter, every week, or maybe even daily. Then the term of annuity from the beginning of the first payment interval until the last payment, end of the last payment interval. And then we'll use two formula. One is for present value and one for the future value of the annuity. Present value represents money needed that to be invested at time zero, so we can draw a certain amount of payments for the duration of the annuities until all the money is exhausted. And the future value is the future dollar amount that is going to be accumulated if we're making a series of payments and adding interest, and that will be calculated at the end of the annuity. Now, small n is going to represent in chapter 10, 11, 12, 13, 14, 15, number of payments is the number of payments in the annuity, and that is calculated by multiplying number of years, T, by number of payments per year, so T times P over Y. Major classification of annuities, we have three categories. Annuity certain, that's the annuity that the term is fixed, so we know that we have a 5-year car loan of equal payments, 25-year mortgage. Contingent annuities that start and or end is unknown. We don't really cover in our course this annuity, but it's nice to know. And if you are ever going to work for an insurance company, life insurance especially, that's going to be a major issue there, and they're going to be using actuaries tables and lots of statistics to determine annuities and calculate those annuities. What we do cover is chapter 13 is perpetuity. Those are the annuities with payments that go on forever. So annuity certain with fixed term we're going to cover in chapter 10, 11, 12, 14, and 15, and perpetuity with payments that go on forever in chapter 13. Further, we're going to divide annuity certain into two categories: ordinary annuity and annuity due. If the payments are at the end of every payment interval, we're going to call them ordinary annuity. If the payments at the beginning, we're going to call them annuity due. So at the beginning of every payment interval. Then ordinary we're going to classify into two groups: simple and general. We just check in number of payments per year. If it's equal to number of compounding periods per year, it's simple. And then we use formula for future value and present value as shown in here. If P over Y is not equal to C over Y, we're going to have a general. and same formula except the i's in here are going to be replaced with I sub 2. Then annuity dues, again we're going to classify them into two categories, simple and general. Again, P over Y is equal to C over Y, and we're going to use modify formula for future value and present value as shown in here, times 1 plus I, 1 plus I, and we're going to note in here due and due. If number of payments per year is not equal number of compounding periods per year, we're going to call them general annuity due, and same formula, but we're replacing i's in here with I sub 2. As far as perpetuities go, very similar. We have ordinary and due. So ordinary perpetuity payments at the end, and if the payments are at the beginning of every payment interval, we call them perpetuities due. And then we have a simple, ordinary simple perpetuity, and general P over Y equals C over Y, a simple formula, present value is equal payment over I. There is no future value because the payments go on forever, and from here we can solve for payment, for I, or for present value. For general, P over Y is not equal to C over Y, and we're only replacing I with I sub 2. For perpetuity due simple, P over Y is equal to C over Y, we're modifying this formula in here by adding payment, so present value is equal to payment plus payment over I. And for general, when P over Y is not equal to C over Y, we're replacing this I with I sub 2. And for all of them, we can use calculator with caution, minor caution. Cash flow diagram for an ordinary annuity. We generally want to show end payments, and then the first payment is at the end of the first payment interval, at the end of second payment interval, and last payment at the end of end payment interval. Then at time 0 is present value. At the end of the term of annuity, we have future value. This is the term of annuity, and those are the end payments. We can modify this. By the way, you don't have to draw like this, but it kind of helps for some people to do this. So just picture that you have almost like a boat with two masts. This one is present value and this is future value. And for ordinary annuity, the first payment we're going to show is at the end. So we're going to show this line in here. And then formula for present value, ordinary PV is in here, and this is future value. For annuity due, the diagram is slightly different. So again, we're going to show that first payment is at the beginning of the first payment interval, so it's right in here. And then second payment is at the beginning of the second payment interval, which is the same, one could say, as at the end of the first payment interval. But the last payment is at the beginning of the last payment interval, so it's right in here is the last payment. And it's still equal to number of years times payment per year, so that doesn't change. The formula is modified for present value. We'll see that modification is 1 plus I and 1 plus I in here, and we write in here due and due in here. I'd like to demonstrate in this example what we're actually dealing in here with. So let's assume that we have 4 annual payments. At the end of every year, we're making payments of $1,000, and interest is 4% compounded annually. So we'll see that P over Y is equal to C over Y, and the term is fixed. We got 4 annual payments, so it's a certain annuity, number of payments equal number of compounding periods, so that's simple, and the payments are at the end of every payment interval, so that's ordinary. So those are the two formula, present value and future value, and we're going to show that payments, and we don't have to show all of them all 4 payments, so generally we could just show that as n is equal 4 payments and payment is equal $1,000, so we don't have to really show with details there. But we're showing in here that the first payment is at the first payment interval, at the end of the first payment interval. Now what is important for us to realize in here, that we have an equivalency. So if I have to make a decision and I have 3 options, I can accept $3,629.90 at time 0, or $4,246.46 at the end of fourth year, or 4 payments of $1,000 each at the end of every year. All of them are equivalent. So it wouldn't make any difference. I could choose any one of them and I'm equal well off. There is no difference because they are all equivalent because of the time value of money. However, if interest rate is 0%, then the present value is going to be $4,000, future value is going to be $4,000, and 4 payments of $1,000 each. Now let's take a look at the first example. Find the future value of the following annuity. You get you are saving $500 per month for the next 4 months, and the interest rate is 3% compounded monthly. So we'll see that P over Y is equal to C over Y. Therefore, use I in the formula. So this is the formula right in here. And you plug in those values in here. Calculate your I. I is equal to J over N. So it's 0.03 divided by 12. And then at this stage, you can go and use your calculator. So let's see how we're going to use the calculator. So we're going to put N is equal to 4. So 4 for N, 3 for I over Y, 3 for interest rate, 0 for present value, negative 500, so that's 500, change sign for payment, 0 for future value. And now we have to go second function, I over Y, and we have a 12, so press enter, and automatically C over Y is also 12. So just cancel this one and compute future value, and we have answer of 2071, and that's what you can do on the final exam. Show your work, and then you can use your calculator. You don't have to show this portion at all, just show your final answer. Let's show your work. If you're using TI 384, here are the financial keys. So you go enter, and then you get 430 500, and you put in here 0 and then 12. Make sure it's E and D. That's what we have right in here, E and D. And then scroll to future value, and then alpha, enter, and you have the same answer. Example 2 is a similar one. So we're going to show the diagram, extract the information, and we're saying again P over Y is C over Y, so we're going to use I is equal to 0.07 divided by 12. Plug into your formula, and then you can use your calculator. So this is for TI Business Analyst 2. And then we can do the same for, so if we're to use TI 8384, input the same information here. We scroll to future value and press alpha, enter, and we have 4,146.9, which is the same as before. Now the question asks us how much interest was earned, so we multiply 48 times 75 and subtract from 4,140.69, so the interest is $540.69. Now we'd like to review some examples from different annuities. So let's take a bullet first. You deposit $300 each for 5 years at 6% compounded semi-annually. How much will you have at the end of that time? So I say 5 years, that it gives me that's annuity certain. At the end of every period, so that's ordinary. And since I have each year, so that's T over Y is equal 1, but C over Y is equal 2, so I have a general because they are not equal to each other. Example 2, find the present value of a 4-year, $3,000 per year annuity at 6% compounded monthly. Payments are at the beginning of every month. So obviously, beginning of every month, that's annuity due. And then number of payments per year, 1, but compounded monthly, that's 12, so that's general and certain. And a diagram for that would be something like this. So we're looking for this present value. We're receiving at the beginning of every payment interval $3,000, and the interest rate is 6% compounded monthly, but number of payments per year is 1, so that's a general and due. Find the present value and future value of the following annuity due. So we have a term 5 years, payments of $50 at the beginning of each month for 5 years at 12% compounded semi-annually. So we're seeing here that we have 12 payments per year, but compounded semi-annually. So we have to calculate I sub 2. So we go and calculate I sub 2. Formula for future value, present value. And we're substituting all those values. And at this stage, we can go and use a calculator. So let's take a look. So we have 60 for N, 12 for I over Y, 0 for present value, negative 50, so 50 change sign for payment, 0 for future value. Then we go to second function, I over Y, and we have 12 payments per year, so that's fine. And then we scroll down to C over Y, we have to override that. We have to put 2 as compounded semi-annually, enter. Then we're going to go to second function, payment, because we have to have a BGN. So second function payment, and then second function enter, and we get BGN. And then compute future value, and that's 4,091.52. Now if you're using TID 384, we do the same. We go to P over Y is equal to 12. Now C over Y we have to overwrite, so that's 2. And then we go to payment, and we have to go to begin and press enter, so it has to be flashing, and then scroll to alpha, and scroll to future value, and alpha, enter, and we get 4,091.52. In this case, we're asked to find present value and future value of this annuity. 9 year is term, nominal rate 7%, payments are $500, compounded quarterly and payments quarterly, so that's simple. We write the formula, we substitute, calculate I is equal to J over M, and then plug into the formula, then use the calculator and calculate first future value and then calculate present value. Last example, we want to calculate nominal interest rate. So we have $465,000, that's a present value. The payment that we're going to be receiving is $4,100 from that registered retirement income fund, and we're going to be receiving that every month, but interest rate is compounded annually. So what we need to do, we have to calculate present value is given, so we're going to use this formula. Present value is equal. Now the problem is that we have everything except for nominal rate. So if we do not have a financial calculator, we have to guess nominal rate, then calculate I sub 2, plug in this I sub 2 right in here, and evaluate this portion and see whether it's equal 465,000. If it's not, we have to do a series of iterations until this side is equal 465, and that could be quite lengthy, and that's what you're going to see in one of the questions in lab 12. If we're using calculator, situation is much easier. Here are the keys for the calculator, and they require interest rate is 9.08 nominal rate. So if we calculate I sub 2, plug into this formula, we're going to get exactly 465,000. And here's the same for TI 8384. So I hope this little summary helps you and prepares you to do some more applications in chapter 12, 14, and 15. Thank you.